All right, so an infinite series means, like last time we talked about a sequence, you're going to take that list of numbers and add it up forever and ever and ever and ever and ever. So you're going to add the numbers forever. This is sigma, which means sum it all up. You're going to have to get used to writing that because you're going to write it a lot. All right, so summing up from 1 to infinity. Now, sometimes this matters and sometimes it kind of doesn't. Don't get hung up on it though. I wrote this one as a 1, just let it go. All right, of the terms a sub n. So it's going to be a1 plus a2 plus a3 plus ... forever and ever and ever and ever and ever. So how can you get an answer for adding up numbers forever? Well, you only can if it converges, not if it diverges. Remember how we talked about that last time, like that asymptotic behavior, like is it headed somewhere? That's how you can add something up forever. So again, it's going to involve limits. A partial sum means instead of going infinitely, you're going to stop at a certain point. So we use a capital S for that, sub n. And so that would mean sum up n terms. So like if it's S sub 7, you would just add up the first 7 terms instead of going onwards to infinity. So it'd be a1 plus a2 plus blah, 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 until you get to wherever it told you to stop. So like the nth one. So like however many you're told to do. So if the partial sum converges to a finite number, then the infinite series converges to S. If the partial sum diverges, it's not a finite number, like it goes to infinity, then the infinite series diverges. All right, so let's do a few of these where we list out. We're going to do like some of the partial sums to be able to write a formula for that. So let's do summing up the first term. That would just be the first term. So if you plug in 1 for this, what are you going to get? 1/2. Good. Don't overthink it. You're just plugging in 1. That's all that there is. So when you do the next partial sum, it's going to be 1/2 plus the next term. So now you're going to plug in 2. So what do you get if you plug in 2? 1/4? You might be already adding it together in your head. And then you add those together, you would get 3/4. Good. So doing the first 3, you would have 1/2 plus 1/4 plus the third one. So if you plug in 3, what are you going to get? 1/8. So that would be, what is that, 7/8? Because this would be 4/8 plus 2/8, so 7/8. Let's just do one more. You're like, how much is she going to torture us? Let's do one more. So this will be 1/2 plus 1/4 plus 1/8 plus what would the next one be? If you plug in 4, 1/16. And so let's see, that would be 15/16. And so now what I want you to do, and this is the hard part, just gonna have to think about it. You need to write a formula for this pattern. So look at the 1/2, the 3/4, the 7/8, the 5/16. I'm gonna hit pause. So the denominator, 2, 4, 8, 16, that's going to be 2 to the nth. And the numerators are always 1 smaller than that. So 2 to the nth minus 1. So that's your formula for your partial sum. Now, if that converges, then so does the infinite series. So we're going to take that out to infinity. So limit as n goes to infinity of this. Good. Let me get everybody else there, though. It's like these are a tie. Oh, good. Perfect. Is everybody there? These are a tie. It's like they're the same. So you're using the leading coefficients, 1/1, which would be 1. Also, you can just look at these. 1/2, 3/4, 7/8, 15/16. Do you see what we're getting closer and closer to? Like it's going to keep on getting closer and closer to 1. So if you kept going forever, the entire infinite series is going to add up to 1. I think that's cool. I realize I became a math teacher, which means I am a nerd, but you can add up numbers forever and get 1. That's cool. Get on board because it's the entire rest of this course, okay? Try it again. This one's just 1. So if you do the first partial sum, S sub 1, that would be 1. Yeah. And if you do the next one, that would be 1 plus 1. So 2. And if you do the third one, that's going to be 1 plus 1 plus 1. So 3. I think that's enough. It would just be n. Nice. Good job. So now we're going to do limit as n goes to infinity of n, which would be what? Infinity. So this one diverges. All right, were we all cool there? Good. The hardest part is honestly coming up with a formula there, which I don't unfortunately have like specific advice for. It's going to come from your number sense, just like practice and doing problems. Okay. All right, so let's try this one, S sub 1. So your first partial sum, we're going to plug in 1. So if we plug in 1, this would be 1 minus a half. So a half. Good. So if we sum up the first 2 terms, it would be a half plus, and now we're going to plug in 2. So if you plug in 2, now here's where it gets difficult for me to keep all these numbers in my head. So I'm going to write this off to the side because this is going to be fun with fractions in a second here. If you plug in 2 for n, you're going to get a half minus a third. So that would be a 6. Because this would be 3/6 minus 2/6 would be 1/6. All right, and then if you add those together, that would be what, 4/6? So 2/3. Yeah, you gotta be good with your fractions on these. We'll just do one more, then we'll try to write the pattern. So if you add up the first 3 terms, it'll be a half plus a 6 plus, now we want to plug in 3. Again, I'm just going to write it off to the side because this is too much for my poor little brain. All right, so if we plug in 3, we're going to get a third minus a fourth, which would be a 12th. Because what that would be 4/12 minus 3/12, so 1/12. So if we add all that up, so what is that, 9/12? So 3/4. Oh, do you see how you're getting better at it, like after practicing? If you just have to do a bunch of them. So what is it? Good. So the numerators go 1, 2, 3. So that's just n. And then the denominators go 2, 3, 4. So it's n plus 1. So we're going to do limit as n goes to infinity of that. Because if you take that sum out to infinity, that's going to add it up forever and ever. Like we just did 1 and then 2 and then 3. But if you did it forever, what is that going to give you? Yeah, again, that would be 1. You can add up numbers forever and get 1. That's sweet. Now, this is what's called a telescoping series. So I was just going to look at that real quick. It's going to be B1 minus B2, and then plus B2 minus B3. Like this is what a telescoping series looks like. And what do you notice is going to happen with all of those? Like, do you see how this is minus B2 plus B2 and minus B3 plus 3? And that's going to happen forever and ever. So you're only ever going to have the first term, and then like wherever you stop, minus whatever that last one is. So S sub n equals that first term minus whatever that last one is, which would be n plus 1. Okay, now that's a partial sum, but say you wanted to take it out forever and ever. This converges if and only if, I love that in math class. It's like the only class where you get to say that. If and only if the limit as n goes to infinity for that b sub n plus 1 is a finite number. And usually it's 0. Like all the typical ones I've seen, like it'll just keep getting smaller and smaller and smaller and it'll end up being 0. But if you do that limit of that last part to infinity, if you get a finite number, that's going to converge, and the sum will be that first term minus that limit. Finite means it's not infinite. So like 2 is a finite number, 3 is a finite number, like a value. Infinity is not finite. Yeah, I guess that's, yeah. Oh, that's a good way of, I've actually never thought of like the dynamics of the word like that, but yeah, infinite. Why isn't it unfinite then? All right, so if you look at the one that we just did, this is going to be, what did it come out to? What was our first one? If you plug in 1, okay, 1 minus a half will be that first one, plus a half minus a third, plus a third minus a fourth. Like, so just for example, that's the one that we just did. And so what's going to happen is these are all going to cancel. And if you want to go out to infinity, it's going to be the first term, so that 1 plus limit as n goes to infinity of the second part of it, that 1 over n plus 1. And if you take that out to infinity, what's this going to equal? Like if the denominator gets infinitely huge, this is going to go to what? 0. So it'll be 1 plus 0, which is 1, which is what we found before. Again, typically, like all the ones I've seen, either this goes to 0 or it'll diverge. Does that make sense? Like usually that last little bit, it gets super tiny at the end and it'll just end up being 0. I was thinking we would do a break there. Do you want to do a break there or do you want to just keep on going? We'll do a break. All right, take like a 3-minute break and then we'll do the other side. Okay, so now we're going to look at specifically what are called geometric series. And we're going to look at these and like later on we're going to look at P series, and we just looked at the telescoping series. So there are kind of like special ones that, that you can be like, oh, if that's geometric, then it follows like this certain property. So geometric series. This one specifically, like it has to start at 0. You can kind of get around that, but the formula, it has to start at 0. So sum from 0 to infinity, a times r to the power n. A is your first term, and sometimes nothing will be written there. If nothing is written there, it is understood to be 1. Okay, so if you see just nothing there, it's understood to be a 1. R is what's called the ratio. That's what you're multiplying by each time. So this would be a plus a times r plus a times r squared plus a times r to the third, so on and so forth. So you just keep multiplying by whatever that number is. So if your absolute value of r is smaller than 1, then it converges and your sum equals a over 1 minus r. Now we say the absolute value of r because it could be negative, and what that does is it makes the terms alternate. Do you remember we had one like that last time where it goes positive, negative, positive, negative? You can kind of ignore that part. So the absolute value of r, if that's smaller than 1, it converges, and then this is how you get your sum. If that absolute value of r is bigger than or equal to 1, actually, I don't know how it could equal 1, because if you just multiply by 1, nothing's going to change. That would, I guess, be like this one. Then it diverges. So you just can't get an answer. Now, the problem is they aren't all written really nice like this, like a times r to the n. Sometimes it's all mixed around and you have to figure out that it's geometric. That's the tough part, is it doesn't jump right out and say, hey, this is geometric. Like looking at this one, 3 over 2 to the n. Well, if you go to rewrite that, you can rewrite that as 3 times 1/2 to the n, and then it looks more like it follows that. It looks like it follows the pattern. So your first term is 3, and then you would keep multiplying by 1/2. So here's the question. Which one of these categories does 1/2 fit into? Because 1/2 is that r value. Less than 1, so it's going to converge, so we can actually answer this question. It's going to be 3 over 1 minus 1/2. So that would be 3 over 1/2, which would be what? 6, good. It's 3 times 2. So when you divide by a fraction, you multiply by the reciprocal. Now, ooh, good. You did this in algebra too. Oh my gosh, I'm going to teach that lesson next class. We're going to, yes. You guys are so brilliant. I can remember everything. I know. Yeah, like we're going to do that next block. Gosh, that's so cool. You guys are all going to like ace the AP. Oh, did you pay your fees? You're running out of time. Oh my gosh, the 9th. Guys, today's the 4th. I'm sorry, Evan, what snarky thing did you just say? So when you look at this one, what's the only difference between these? Because I only changed one thing and it's really tiny. Okay, so instead of starting at the zeros term, because geometric, it starts at the zeros term. This time we're starting at 1. You can still get around it though. You would take what this answer is and just subtract off the zeroth term. So if you want to start from 1 onwards instead of 0 onwards, you take the whole thing and just subtract off that zeroth term, which would be 3. And so your answer would just be 3. So where I was headed with that, and I typed it on here so you wouldn't have to write it, whether it converges or not is not altered by leaving off the first few terms. So if this converges, this also converges. So let's compare and contrast those. For this one, what is A? It's not written. A is 1, good, perfect. It would be like if you were to slip a little 1 in between here. In fact, you can rewrite it and write the 1 if you want. R is a half. So when we go to find that sum, it would be 1 over 1 minus a half, which is going to be 1 over a half, which would be 2. So when you compare that to this is still going to converge. It just didn't start at 0. You take this answer. So when we go to do this one, you would take this answer and you have to subtract off however many terms are missing from the beginning. So we want to start at 4. That means we have to subtract off 0, 1, 2, and 3. Does that make sense? 0, 1, 2, and 3, we have to subtract off. So the 0th one was 1. And then the next one would be, you just keep multiplying by a half. So the next one would be a half, and then a 4th, and then an 8th. So you can still get the answer even if it doesn't start at 0, but just remember the formula starts you at 0. So if it's not 0, you take that answer and subtract off the first few that you're missing. Is this making sense? Like just leave off the first few. All right, so looking at this one, what is A? 1, good. What is R? 3 halves. Now, what does that mean? Why does it diverge? Good, so here's how you would write that. Diverges, because you would need to give a reason. Because R equals 3 halves, and that's greater than 1. Now these two, 7 and 8, they don't look geometric. And that's what's tough about this on the AP exam, because all these are mixed up and you don't know which ones are geometric and which ones aren't, and all of that. My suggestion is write out the first few terms, okay? Because that will give you a frame of reference. Now this one's starting at 1. So let's plug in 1. If you plug in 1, you're gonna have -8 over -3. So 8/3. Now, if you plug in 2, you're going to have -8 over 9. What are you going to get if you plug in 3? -8 over -27, good, so it'll just be 8/27. That's good enough. I would say do 3 or 4. If you're good at 3, you can stop if you need 4. If you need more, do more. But let's go ahead and rewrite this so that it looks geometric. We're going to start at 0, go to infinity. You're going to draw a lot of sigmas from now until the end of the year. So like, yeah, get on board with drawing that. What was our first term? Or I guess I should stop saying first, the 0th term, which is the first one that's there. But Anyway, that one, 8/3 times r to the nth. R is however you generated the pattern. So it's what are you multiplying by each time? And I think it's easiest to do the numerator and denominator separately. What are you multiplying by in the numerators? -1, good. And then what are you multiplying by in the denominators? 3. So now we have it written correctly. Phew. All right, that wasn't that hard. We got it. Can we actually do this problem? Will this converge or diverge? It converges because absolute value of 1/3 is 1/3, and that's smaller than 1, right? So it's going to be 8/3 over 1 minus negative, so plus 1/3. It's a over 1 minus r. It's just r was negative, so they canceled out. So that would be 8/3 over what? 4/3? And then the 3's are going to cancel. So 2. And once again, you can add up numbers forever and get 2. It's cool. All right, again, this one looks like fun. It is geometric, it's just you can't see from looking at it. So let's generate the pattern. Let's plug in 1. If you plug in 1, you're going to get -2 over e squared. All right, what do you get if you plug in 2? Four over e cubed, good. And if you plug in 3, -8 over e to the 4th, that's probably good. Let's rewrite it so that it looks geometric. We're going to rewrite it with that pattern. So what would go in here? Good, that's the first one, or the 0th one. R to the n. When you figure out r, do the numerators and denominators separately. What are you multiplying by in the numerator? -2. And in the denominator, you're multiplying by e each time. So now, does it converge or diverge? Well, forget that it's negative because we absolute value that anyway. This is 2 over e. What is e roughly? 2 point something something. The point is you have 2 over a number that's bigger than 2. So that would be smaller than 1. So we can do the problem. All right. So it will be -2 over e squared over 1 minus negative, so plus 2 over e. I'm going to have to come down here because I ran out of room. So -2 over e squared over, I'm going to think of that 1 as e over e. If you think of it here, I'll just go ahead and erase it. Think of that as e over e. Why would I do that? Yeah, like a common denominator. So this would be e plus 2 over e. And when you divide by a fraction, you multiply by the reciprocal. So I just flipped this over. And then all you can really do there is one of these e's is going to cancel. So final answer, it'll be -2 over e times e plus 2. Really, like, why did she make us do this? Can't we just stop here? Only if it's free response. If it's multiple choice, you have to keep going until you can get an answer. And I put this last one on here because this geeks me out and I think this is cool too. 0.7, and what does that bar over that mean? Yeah, like so 0.77777 forever. If you wanted to write that as a perfect ratio, I'm going to write it as a sequence of, or I guess I should say series of numbers we're going to add up forever and ever. 0.7 would be 7/10. Or you know what, actually, let me write it as the decimal first. I'm eventually going to go to a fraction, but you know what, let me write it as the decimal first. So you'd have 0.7 plus 0.07 plus 0.007 forever and ever. If you added that up forever, you would get 0.7 repeating forever. Do you get what I'm saying? Like, just keep on going. So let's write that as a geometric series. It would be 7/10 here. This is what I was thinking of, because I think it's easier to write it as a fraction here. 7/10 r to the n. What are you multiplying by each time? Well, I'm going to write it as a fraction if that's okay. I just think it'll be a little bit easier. So 1/10. You're dividing by 10 each time, so 1/10. So this is where you're starting, multiplying by 1/10 each time. So it would be 7/10 over 1 minus 1/10. And so that would be 7/10 over what? 9/10. 10s cancel. 7/9. If you don't believe me, go ahead and type 7 divided by 9 in your calculator.